same thing is your shear stress is equal to VQ over IT. Okay. Anyone have any questions so far? You are okay with when we label it as a flange, when we label it as a web? Yes? Now, let's look at another section. Okay, let's look at a white flange. Okay. I hope online you guys are okay. Okay, anything online you can just type or you can speak out. Okay, I will respond to your questions also. So now let's look at the white flange beam section. Okay, so let's look at. I will try to make sure they're all. Yeah, I can still put this here. Okay. So now let's look at an I-beam, a white flange. So this is our white flange. Okay. That's our white flange. So now our shear force is coming down here, Vy. Okay. And again, we will label this as our flange. This is our web. This is our flange. Okay. Then I'm going to construct our shear flow again. Okay, that's how our shear flow is constructed. So that controls the flow of the shear flow. Okay. So what I want you to think about this is think like fluid flow. Okay, that is like your mainstream. Okay, where the flow is controlled. So what you see over here now is you will have terminus over here and here, and the flow will go this way. And this will go the other way. Okay. Then likewise, if I have, so you can see down here, there are 4 terminals down here, okay? So likewise, so again, at the terminus, where the dots are, so all these are your terminus. Yeah, the blue dots are your terminal. The shear stress is always equal to 0. Okay, so I'm going to draw horizontally now. Yeah, I'm going to draw the applied force is horizontal now. So what we have here now, this is our EZ. Okay, our VZ is acting that way. So again, I'm going to construct our terminal. Okay, now this one is going to be really, really interesting. Okay, I want you to see this. Okay, so again, we label this as our web. This is our web. Now this is our flange. Okay. So now our shear flow will go this direction. The web controls, right? So that's the mainstream, but you also have fluid coming in or going out. It's up to you. You want to draw inwards, outwards is fine. So over here, you have another terminal. So when two opposing arrows comes together and meet at one point, we call it a terminal also. Okay. So at the terminal again, the shear stress is equal to what? 0. Yes. Why is the terminal over here? Yeah, this is because you are visualizing the terminal has to start from Vy. Okay, for a structure to be loaded this way, usually it has to be doing this. So this is Vz half, this is Vz over 2. Okay.
Sir, I have a question.
Yes.
So as you mentioned, so when there are two arrows going towards each other, so we will have a terminal, right?
Yes, because
In the
they
second,
cancel out one another.
right. So in the figure one, when we are having a Vy from the top, from
Yes.
the y-axis, why don't we
Yes.
have terminal on the like in the middle of the flange? Because the arrows are coming like in the center. They're
No, it will not have because the fluid can go down the web.
oh okay. Okay, so there is if there is no flow like to okay
Yeah,
okay.
if there's
Got
no
it.
flow, it cancel out one another.
Yeah, okay, okay,
Right?
okay.
So the web, so that is why I keep on emphasizing the web controls the flow. Okay.
Okay.
Did,
Yeah.
did, did you all hear that question that he asked? Yes or no? Can you all hear? So I have to repeat. Okay. So the question asks, why is this point not a terminal? Right? You have fluid from one side, you have shear flow from the other side coming together. Right? Remember I say coming together can cancel out. This case, no, because it can go where? It can go down. Okay? Whereas this case, it has nowhere to go. That is a very good question. Okay? That's really, really a good question. Yeah? It has nowhere to flow, then we classify it as a terminal. Then at the terminal, the shear stress is equal to what? Equal to 0. Okay? Right. So now you can see how we design shear flow. I'm going to make things not ugly, but see, let's do some example. If I have any, okay, I will draw an example for you. Okay, I'll draw an example. Okay. Oh, I'll let you guys finish copying first. If those online are copying or yes, you have question? Are you okay? Okay. Now, if you have to drink water in class, you don't need to step out. Just drink water and put your mask back on. Okay, don't like I have to drink water, go out, come in, go out, come in. It's ridiculous. Okay, we do things that are practical. Okay, as long as you don't unmask and start yapping, I think it's fine. Okay. Okay, then let me draw another another one. Okay, I will draw another structure. What if now the structure looks like this? Don't worry, I'm not drawing a St. Andrew's cross, okay? And then the shear flow comes from this direction, or the shear force comes in this direction. Okay? Yeah, right? So you can see, okay, now you can see is the shear flow now, right? The Q will now go this way. I construct that first because the web controls the flow. Okay? Then from here, so if you look at terminals, how many terminals we have? Okay? You have terminal over here, 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 terminal over here. Okay? So this is one really complicated structure. Okay. Now, if okay, watch this. Okay, so at the terminal, the stresses are equal to what? 0. Okay. Now, what will happen now if we are interested about the shear stress at point A? What is the area, first moment of area that we take? Remember, the formula we are going to apply, there are only two sets of formulas, still the same. Okay, Q is equal to VI over T, VI over VQ over R. Okay, so there are two formulas I'm going to write to you. The shear flow Q is equal to VQ over I, or the shear stress is equal to VQ over IT. Formula is still the same. The problem now is this. The killer thing is always what is your what? First moment of area. V and I are easy. Thickness is easy. I'll later teach you how to define what is the thickness. Okay. So if it's point A that you are interested, right? The area of consideration is this. Now let me copy because I have to do other example. Okay. If point A is of concern, this is the area that you should be acquiring for your first moment of area. Okay, so everything is relative to your terminal again. Yes or no? Okay, so this is your Q for point A. Okay. Now, what if now? Okay, what if now we want to find a different point? Okay, we want to find at point B. Okay, I will highlight where is point B. Okay. So could you label the flange and web? Okay, so if that's the case, for this case, this is known as our web. Okay, so I'm going to divide it this way. And these are known as our flange.
Sir, one other question. Those arrows that are going on the flange, they're going outwards. You said that I could presume that they could be going inwards as well, right?
Yes, the analysis will still be the same.
Okay.
Okay,
Thank
it
you.
can also go inwards, is fine. Okay, so what student mentioned, okay, I'm going to draw another, no, I will not use the same. Okay, I'll copy. This have the same thing. My bad. So if you construct your shear flow in this direction, okay, let's say you decide to construct your shear flow in this direction. Wait, let me wipe this out. Yeah, right. You know what? Sometimes you're better off redrawing the whole thing. Okay. Okay. So you can also construct your structure or your shear flow in this orientation. Okay? You can also construct it this way. Oh, no. It has to be. So this one, you also want to construct this way. It's fine. It's still the same. It's no, yeah, it's correct. Okay. The terminal are still existent. Okay, the same position. So again, on the right hand side, if you construct it that way, at point A, right, the area of consideration is this area. Do the same. Okay. Now, what if now? Okay. I'll let your copy first. Okay. As I say, this is one of the worst that you can see. Okay, you cannot see any worse than that. Okay, it gets confusing. Now, what if now, right? You want to find okay, we want to find at point C. You want to find the shear flow at point C. So to find the shear flow at point C, this is the area that you take. So I will section it this way.